Okay. Um. Okay. So crazy stormy out right now, like insane. Um. So I don't know. I don't know how spotty the service will be. It looks pretty strong right now, but it is pouring like crazy. There's thunder. There's lightning. Um. But it's all good because we're making progress. We're uh we're making progress. So few updates on everything. I have now I have less than 2 weeks to finish 2 videos. Um, the builds aren't done yet. Haven't started filming anything yet. Haven't worked on or haven't I've worked on a script. Haven't really gotten anywhere with any of the scripts. So it's gonna be. I literally haven't even started a filming anything or started a Final Cut file for either of these videos yet. It's going to be nuts. I don't know how it's gotten to this point, but the pressure's on, and I'm feeling good. The pressure's on, and I'm feeling good. Let's see how long that good feeling lasts. Um, I've been definitely like spending a ton of time on what seems like little details, but it's actually I think it's actually going to make the difference. The siren video is taking a bit of a different turn because it's going to be slightly more casual. I think less scripted, more just like testing things out. It's not going to be like a complete build video because the build isn't actually that interesting. What's more interesting is like what can we do with this thing. So that's sort of going to be the theme of that one, and obviously I'll have the history and stuff involved. I think that's really interesting, but it's this video is going to be interesting. I don't know exactly what I'm going to do yet. We'll see. We'll have to see in the edit, I think. The kick drum pedal video, though, I think is going to be really cool. I do have a little bit of flexibility on the timeline. I think I might be able to extend it a little bit, but I'm hoping I don't have to. And I really want to push through and make it happen. So it's crazy how quickly this deadline came up and how far behind I feel like I am. I've been working on this like basically every day. Um, this isn't the only thing I do though, so obviously I'm limited, but um, and then I got to get started right away on the next one. So we're gonna have to see. We're gonna have to see where either of these videos go. Um, but hopefully, when I start working on the next one, it's the only video I'm going to be working on, so I'll be able to crush through that. Pretty. It's been hard to stay focused, I think, is the thing. Working on 2 videos simultaneously, it's been hard to stay focused. It's been really hard to manage my time, and I think I get bogged down on things, but it has also been kind of exciting. So, I think for today, I have the pedal mechanism assembled, and it pretty much works. I want to wait for some of the folks to join before I show it off, because there's a couple people that have been there throughout the long process of figuring this out. So I want to wait for at least one of them to show up, and I can share it with them and everybody else. But in the meantime, I think we can maybe play around with the new siren. I gotta set up a better camera situation. I have my phone that works as a decent camera. Maybe I'll just do that. Like maybe I'll kind of do like a back from the back shot. This is broken, though. This is broken, though, so I don't know. I guess until anybody joins, I could just model this up quickly and see if I can fix this, because that would be ideal. I really don't want to have to do this, though. I could just glue this as well. Maybe I'll just glue this. Yeah, and then as far as like what I'm gonna do on this stream, I think I'm just gonna kind of keep doing what I've been doing. I have a bunch of discs printing for the Siren. The Siren's working pretty well. It's definitely an experimental instrument. It's nothing crazy. There's nothing insane about it, but I think the creative potential for it is cool. So we'll play around with that a bit today, I think. Kind of show off what it can do. Maybe figure out how to use it in the video the best way, because I'm not sure if I want to actually like record audio for the video, or if I just want to record the audio in the room through the speakers. That seems like the easiest option, so might do that. I don't have any glue in here. I don't have any glue. What time is it? I think I started a little bit early, right? So, okay, yeah, so it's 3 o'clock now, so should have some folks starting to join pretty soon here. I would like to set up, I guess I could just use this camera. 1 second here. Cheesy Michael, open up the door. Cheesy Michael, open up. Just got a wood hookup. Hopefully. I'm like the guy in town that collects pallets from all the stores, and I use it to build stuff around here, because I'm very cheap. But also, pallets are fun to build with. I find them useful for farm stuff, especially. Okay. So, setting this up. Let's see. Whoa. Let's see. Camera 2. You working, dog? Why ain't you working? Let me get this working, dog. Video, iPhone. Maybe that's a dumb spot. Okay, just give me a couple of moments here. That's cool. Ooh, you could see the new printer setup. Okay, I don't know why it's not working on this. Let me just video capture device. Nope. There we go. It's upside down. Why is it upside down? How do I view? I mean, I could just flip my phone, I guess. No? Can I not just flip it? So confused. Whoa, why doesn't that do anything? Okay, hang on. I flipped this before. Transform. Rotate 180. There we go. Boom! Boom. So, you can see, new printer setup. A couple new printers there. That's an 8-foot... That's an... Oh my gosh. That's an 8-foot long desk. With a stone top that I got for free on Marketplace. And I love it. So, I thought, yeah, we can mess around with the siren here. That's why I turned this. Sounds like one of the test discs I want to play with just finished. So I'm doing a little bit more of like a specific sort of testing regimen on this. This isn't fully built or assembled either, so that's another thing I got to do. I gotta fully build and assemble this thing, but let's play around with it first today. Gosh, you can't really see this, can you? Hold on, let me reorient this a little bit. It's super zoomed in too. Maybe that's the issue. Hold on, let me see if I can make it less zoomed in. Yo, Ruby. Yeah, I'm just trying to get... There we go. That's a little better. I just wanted to get the angle right so I could actually show off some stuff. Not on the webcam. Since you're here, Ruby, I'm going to put this to the side for now. I'm going to show you the real thing. Oh, how's my audio actually? Is it coming yeah, okay. All right. Here we are. It's not perfect. There's a lot of things rubbing against each other that are preventing it from having full motion. Like this should be able to come back further than this, and it's not because there's a screw. And it's also not perfect. Like I tried playing it, and there's definitely things we need to fix. But check this out, right? So you press down. Once you get to the screw there, the jack releases, it goes back, and then the linkage does its job and flicks it back under. How cool is that? It actually works. Okay, let me get some closer angles here. Just using my phone as a camera. Yeah, look at this thing. Look at this thing. This camera angle sucks. So it comes forward. Look at how well this guy moves. Right? This guy actually moves really well, but once you go there and it goes back, it clicks it forward. I can't believe I was so stoked yesterday. Okay, let's see if this is a better angle. That's kind of a good... I'm trying to find the best angle. There's not a lot of room on my desk to put stuff. I really need to have a better setup for these live streams so I don't have to... Okay, there we go. That's pretty good. It actually works. Now, there's issues with it, like... Well, for one, I'm using these dumb big screws. This is all I had, and so this whole thing's really wobbly. And I was like, there's no way this is going to work. This is so wobbly. It's not going to work. I'm going to have to refine things to actually make it work. And it actually still works even with all of these like really bad inconsistencies. But it works so well. Now, so the issues are... There's a few issues. So obviously the sound, it's a loud, like the clicks and stuff. That's loud. that shouldn't be so loud. But really, that's all that is this guy going. So we're going to fix that with using multi-material printing and putting pads on everything. That'll be fine. The other issue is that it takes too long for it to re-engage. And also it bounces when it hits back here. I'm hoping the padding, we can come up with a geometry that will make it catch a bit better. It's not bad, but I think we can prevent the bounce, especially because TPU is like anti-bounce. It's soft and it doesn't bounce. So it's kind of the perfect material for this. But it takes a little bit too long to get the jack back underneath. And I think what we're going to do is probably try and reduce the tooth size. Make the tooth as small as possible. We'll do a bunch of iterations, really get this whole action super minimal. And probably actually reduce how much it falls back. It doesn't need to fall back this much. I think we could probably make it so it falls back, you know, only like that much, and then that gives it a lot less work for this to do. But it works. It actually works, and I can play with this now. This does play on the kick drum, but because it's slow to go back. The quick hits, which is the whole point of this, the quick hits sometimes don't trigger properly, and the noise is just too much. So we're gonna definitely, I guess that's what we could do today. We can go into the design and make this all really quiet sounding. But my God, this is such a satisfying thing. And then when it goes back too, it works. Hey, Cogs, the viewer. Yeah. So this, basically what this is, and just to summarize it for anybody else that hasn't seen this and is going to watch this after, I wanted to take a regular kick drum pedal and make it operate like a piano key. So in a regular kick drum pedal, when you press the pedal down, the pedal's directly linked to the cam. So when you press the pedal down, the beater... Hold on, let me get further away here. So, when you press the pedal down, the beater swings forward and hits the skin of your drum, right? And on a regular kick drum pedal, if you hold your foot down, the beater stays pressed up against the skin. And on a regular kick drum, that's really not that big of a deal, but it does kill the resonance of your kick drum. And so if you wanted a big boomy sound, you need to practice not doing that. And it's called burying the beater when you play and you let the beater rest on the skin. And it's actually, as a drummer, I prefer burying the beater when I play a lot of the time. It just feels better. But what if you don't always want to bury the beater? And so what if there's a way that we can make it so you simply can't bury the beater? And it turns out a piano key does exactly that. When you press down on a piano key, it launches a hammer forward, but it allows the hammer to bounce back after it hits the string. And that's why when you hit a piano key and you hold the key down, the note sustains. And it's not until you actually lift your hand off the key that it dampens the string again. And so that is something I want to add to this as well, is I want it so that when you press down, the hammer hits the skin and bounces off right away. And then when you release the pedal, it actually then has something that goes and dampens the skin. So it'll add a level of playability that's not normal on a regular kick drum. And you can see here we have the first two actions where you hit and the beater bounces away. And then with this crazy linkage, it re-engages. So I can explain why this linkage was so difficult to do and Ruby kind of explained it a little bit too. So basically, if you take all this linkage stuff away and you're looking at just this jack here, this piece, which we're calling the hammer butt, and this is actually independent from the actual cam. So you can see this moves without the pedal moving. And then the main cam here, which rotates as you press the pedal. So when you press the pedal, the jack, which is sitting underneath the butt, the hammer butt, is pushing the hammer forward. And because there's a spring here, the hammer stays mostly in line. And so the idea is you want to be able to launch the hammer forward. The jack hits this screw, lifts up, and you see how it launched the mallet forward when you do that. So now the jack is lifted up. So the big issue before all this linkage stuff happened was, how do you now get the jack back underneath the hammer? And there's plenty of ways you can do that. And, you know, realistically, I could have basically just copied this jack mechanism and had it over here. But like Ruby said, I wanted to find something that was as low friction as possible. I didn't want a lot of parts like hitting each other, so I could have done some sort of cam follower. I could have done some sort of thing like this, but I wanted to reduce the friction as much as possible. And so the hard part about it was I needed something that when the jack lifts up and the hammer falls back, I needed something that would hold the hammer in place to allow the whole mechanism to rotate back underneath. But then once the jack is back underneath, this thing that's holding the hammer needs to get out of the way so that the hammer can actually fall back fully. And for whatever reason, it was an extremely complicated thing to figure out. And basically this little guy here does all the work. You can see how it gets out of the way throughout the stroke. And actually, if this pedal could go further back, which it can't right now because there's a screw, one of these screw joints is in the way. It's getting caught on the frame. But you can see how this screw moves out of the way of the part that it actually pushes into as you come down. So that was one sort of requirement of the linkage. That couldn't be in contact with that point throughout the rest of the stroke. But then it needs to hit that. It needs to hit this little contact point on the hammer. It needs to hit that at the very specific point where the jack, right before the jack lifts up. And then it needs to yeet out of the way the second the jack lifts up. So you could see how this little screw gets closer and closer to this plastic part. They're all plastic parts, but you know what I mean. It gets closer and closer, and then it finally touches it here at about this point. They're in contact right now. But then as soon as the jack lifts up, it falls back out of the way, which allows the hammer to fall back out of the way. If it didn't fall back out of the way, the hammer wouldn't be able to fall back. So you can see now that with the pedal fully depressed, as you release, that screw engages with that little thing, and it pulls the hammer back up so that the jack can re-engage. And it works. And I can't believe it works. But I also can, because we literally spent like six or so streams just like trying different mechanisms. And I didn't even print any of them until I could verify in the software that it might work. And so this was the first time that I had a design that I was like, okay, this could potentially work if I print it. And it does. And that is crazy. So 6-bar linkage, very, very, very hard to figure out. Not all linkages are hard, but like basically I needed to find an exact path for this to take, and so it was kind of a nightmare. But but we're there. We got this working. So it's all about refining this now. We are going to work on reducing the sound, improving the speed, and like obviously making sure there's no areas where the screws getting caught. I also want to figure out these screws work well, honestly. It's not that big of a deal, but I think I can do something better. And what's cool too, this isn't going to happen, but this shouldn't happen, but if for whatever reason your jack comes off well down in the stroke, you still get, it is the cam mechanism that is pushing on the hammer now, which is really cool. And it will reset itself. Oh, and I was playing with this all night last night. My family was probably losing their minds hearing all this clicking and stuff, but it's just so satisfying. It's so satisfying when it works. So that's that. That's working pretty good. I'm printing a bunch of discs for the Siren right now. I really like the design. I'm really excited to see what you're going to end. Thank you. I think I'm going to the ultimate goal for this. The reason I'm actually doing this, I don't know if you ever saw my world's smallest kick drum video. Let me change the camera here. I don't know if you ever saw my world's smallest kick drum video, but basically I tried to make a tiny little kick drum, and I failed miserably, and that's my least favorite video I've ever released. And so I've kind of always had this idea that I'm gonna be able to figure out this world's smallest kick drum thing. And one of the things that has held up a lot of design options, because basically in order to make the world's smallest kick drum, I need to not do a skin. The way a drum works, obviously, you hit a skin, it vibrates, but the whole drum vibrates. And so the bigger a drum is, the lower the sound is. So to make a tiny kick drum is like, it goes against the laws that every drum ever has worked on. So to make a tiny kick drum, I need to abandon the skin, and I need to use something else that vibrates at a low, like 40 hertz rate. And so, there's a few options, like using tongues or using a spring or something, so that when you hit this little drum, it vibrates at that slow rate. But the big problem that's always sort of plagued that idea is that a lot of drummers will bury the beater. So a lot of drummers will play it with the beater resting up against it. On a big kick drum, it doesn't really make a difference, because a big kick drum, when you bury the beater, the rest of the skin still does vibrate, and the rest of the drum vibrates. So even though you're getting less resonance out of the drum when you do this, you're still getting enough that it sounds like a kick drum. But in the tiny little kick drum, where that strike surface that this is supposed to hit will be responsible for 100% of the tone of the drum, and is the only thing that will be producing that tone, and it's so small that if you were to bury your beater into that, it would 100% kill any kick drum sound out of it. So my idea was that with a kick drum pedal like this, where you literally can't bury the beater, because if you try, it just bounces away. There's no way to actually bury the beater in this. So it'll always give you a clean hit. And that was the actual inspiration behind this. But in reality, it was just a great, it was a great learning experience to try and figure this all out, because the piano key mechanism itself is such a beautiful mechanism, but it doesn't look anything like this. In fact, it does a lot of things really differently. So it was kind of an exercise in reverse engineering, but then also adapting it to something totally else. And I don't know if I'll get it to work as clean as like a regular piano key, because a regular piano key is a lot lighter than this. This is obviously a huge hammer compared to what you'd find at a piano. So a piano key has the benefit of like way lighter parts. And it's also laid out completely differently as well. So this, as long as I can get it to work in theory and like actually demonstrate that it kind of works, I'm happy. If it's not as playable as a regular kick drum, that's fine for now. I could always do a V2 if people are really interested in this. But I just wanted to get to this point, honestly. This is all I wanted. I wanted to be able to get this mechanism where it flicks back and then re-engages the jack. So, I can't imagine how you could fit that. Yeah, did what I say kind of answer that question there? This looks nothing like a piano. What's crazy about a piano key mechanism, though, is like each key has that same mechanism, and there's 88 keys per piano, and there's 90 moving parts, something like that. I've seen different numbers, but like average, like 90 moving parts per key. So, it's just a crazy amount of mechanics that goes into a piano, and it's like it hasn't changed in like 300 years. So, anyways. So, let's jump into the software and let's see if we can improve on this. Because I would love to see if we can make this work even better. And I think we can. I think it's going to be relatively easy. Yeah. So, and then we can do the siren stuff in a minute, or like later. I'm printing a bunch of discs for it right now. I think one just finished. But there's still a couple more printing, so we won't test that until all of them are done. Okay, so that's not correct. Hang on, let me just figure out what is happening here. There we go. Okay, so this is our mechanism. I think I'm going to print all the parts in different colors so I can refer to the colors when explaining it. I think that'll make things really easy, but I want to pick colors that look cool. I don't want to just do random colors like this. Like I feel like red for this makes sense. Anyways. So the first thing I need to do is I need to dampen this guy. And I think literally all that's happening is this guy's just bashing into there. So we just need to put a little bumper on this. Oh, and actually while I'm here, I can show you. Oh wait, I can show you. Oh my gosh, so messy. So messy. I'm still in the middle of cleaning all this, but that's the new printer stations, that half of the room now. That used to literally just be garbage, and just like stuff I would trip over. But now that's going to be a new manufacturing station, so all the printers are going to kind of live over there. I might keep one behind me sort of at all times, but that's going to be the major like workhorse part of the shop. And then we have the laser there and everything too. And there's a little cubby here where I have another printer, but I'll probably put maybe filament closet or something in there. But yeah, it's coming along. This desk is so nice. I'm so happy with this. It's super, super sturdy. It's got a stone top, so those things, they can't, having all that mass underneath is really helping with keeping things stable. Okay, so what are we gonna do here? Just give me 1 second. Just want to turn my phone camera off now because I don't have a charger in here, and I don't want to just unnecessarily kill the battery. Okay. Sorry about that. I got a little bit distracted there. So, okay, there we go. So, so I basically want to just add a pad here, but I don't want to just do a straight up. Like it kind of has to be. I want to do something that looks good too. That's one of the things I've been really working hard on, is trying to make things look better, because I feel like my designs have suffered in the past, or my videos have suffered in the past because of things not looking that good, which feels dumb, but I get it. So, thinking, why is this in this shape anyways? I feel like this shape is actually kind of dumb. It doesn't need to be like that. Like realistically, this could just be parallel. Okay, let's just do that. Parallelize that. Yeah, so I'll cut all that out and add some stuff there, so it's just a straight up thing. Oops, what? Oh. Huh. So confused. What's happening here? Why is my sketch not showing up? Oh. Oh. Boom. I need to get better at this. I need to get better at this software. Okay, we can pull that back. Feel free to keep chatting. Sometimes when I'm working on this stuff, I forget to talk. So, I obviously want this to be fun to watch. Don't want to just be doing this. Dun, 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 dun. So I'm kind of thinking something like, oh no, I need that corner to be, I mean, literally just basically, I'm thinking about just making this little nubbin soft. But I think I need to do more than just, like, I don't think it can just be a solid piece of soft. I'm going to have to add something. And then I also need to make sure it's like, hold on, I'm trying to figure out how to explain this properly. Maybe we do something like that. So it's going to be this whole section, and we can tie this in with, actually, I should make it almost removable, shouldn't I? No. Let's print it all in one. It's easy enough. So if I extrude, yep. Okay. And then I extrude this again to there, make that a new body. And then change the color of it to red. So there's our first pad. Now, what I was saying before is I think I need more than just a solid pad because my soft material isn't that soft. And it prints flat on its back. So I think I'm going to add like maybe like ribs to this. You know, so just like, would it maybe be better to be modular so you could try different things instead of having to reprint the whole with multi-material? It would be better. I want to demonstrate the multi-material printing. That's kind of one of the benefits of doing this, is because I can show off the multi-material. And this piece prints in like 15 minutes anyways. Obviously with multi-material it would take a lot longer, but I think it's worth it to demonstrate the capabilities. And I want to experiment with how this multi-material stuff works. But in the real world, yeah, I would totally make this a separate thing that slots in so I can change the pads. And what I can even do is probably redesign this later. Actually, you know what? Let's do it. Let's make it so it can slot in. So I'll still print this in one go, but then I can be like, in reality though, I'm going to do this in two separate pieces. This is Fusion 360. I like it. It's not free. I have a hobby license that I think was pretty cheap. I honestly don't remember how much it is. I think it's like $50 a year, but that only lasts for 3 years. And then after the 3 years, you have to get the pro version, which is like insanely expensive, I think. It's something dumb like that. And they changed it. It wasn't always like that. Fusion 360 used to have a straight up free tier that anybody can use. And then they took that away. And the only reason I use Fusion 360 is because it has CAM software. So I can actually run my CNC machine, which I have in my garage. I can run my CNC machine with this, but I haven't used my CNC machine in years. and I'm struggling to justify having to buy the full premium version of this. I want to try. I've used Onshape before, which I know has a free version and is equally as powerful. I don't think it has the cam software, but I do know the free version is like fully capable. The only issue is, I think if you're using the free version, then all your designs are public, which for me it doesn't matter because I make my designs public anyways because I'm making videos about them. But obviously that's not ideal for certain things. So those are sort of the options I know of. I haven't experimented with anything else. So I'm thinking about doing like kind of like a I guess I want something that looks cool. You know what I mean? Like that looks kind of cool to me. I was thinking about basically doing like something like this. Something like this. And then something like this, maybe. And then something like this, maybe. This all makes sense in a second, I promise. And then something like maybe that. And then something like this. Oops. Like this. Holy cow, stop texting me. I have a real estate agent that texts me all the time. Okay. This might be dumb, but we can try it. We can always change it if it doesn't work. And then combine this with this. Sketch away. So something like that. And so obviously that should be able to slot in and out. And then again, let's do a let's start with minus 0.5 like that, and then maybe come straight up here. And then like 0.7. And then like, I don't know, that, I guess. And like this and this. Like that. And then this. Wait, actually, no. But that's kind of the shape I'm looking for. Let's take these. Oh, that does not work. Okay, that's okay. So we're going to come forward with that. what's our distance between these? Ooh. 4.565 mils. That's a dumb amount. .56 mils, hey? Well, let's... create a rectangular pattern. Hello, mother-in-law. Common guests on this show. My wife and my mother-in-law. Very sweet. So what was it? 4.565? Oh, but minus. That doesn't work. .65? Oh no, 4.065? Okay, I'm just going to eyeball this because let's be honest. .16, I guess. Okay. And then let's do 7 of them. Okay. So that's what I'm thinking. Just a nice little, you know, those will take an impact, but it won't be loud ideally. So we could try that. Now we can finish that up. So now let's look at this. One of the things I wanted to try with this was just like really reducing this as much as possible. So one of the things I was thinking is first let's fix the jack. I think one of the things I'm going to do is just get rid of the chamfer altogether. And maybe make this... Oh. No. Okay, never mind. Maybe fillet this. Like that. Okay, so now we just have a really sharp edge right there. And so, actually, we should probably keep it like this. Maybe I can do a little fillet on this. Yeah, something like that. Okay, and then I'm just going to play around. What I'm actually going to do is... So one of the things right now, this guy bumps into this screw, and I want to play around with that. There's my wife. There's my wife. Is that a bacon? Is that a bacon? I can't tell what that is. It looks like a bacon to me. So yeah, what I want to do here is I want to actually grab this, create a copy, move it out here, and adjust this a bit. So let's bring this in. It's not going to let me do that. Okay, great. Love that. Can I get rid of this? Yes. And just add a fillet here. And like, let's make it small, right? Let's see what just making it small does. Tiny little guy. And then in order to make it maybe not bounce back as far, because right now it bounces back and hits the screw here. I guess what I can do is I can just print a TPU bumper that goes on the screw. Then I don't have to change this at all, which is nice. So maybe I'll do that. So, and there's nothing, oh, right, wait, the jack sits there. Okay, yeah, so something in between the jack would be really nice. So let's just do this on the jack. And I'll create a sketch here. I'll project that. Let's make it maybe 10 mils. Oh. Can't really do that because the actual thing needs to rotate. Okay, so I can't do it on the bar. Well, actually I can. So here's what we're going to do. We'll do another multi-material thing. Just, you know, just for no, that's going to print dumb. That's going to print dumb. I don't want to do that. Okay. Okay, we're going to not do it on the jack. We are going to do it on this guy. Because the bolt sits right up against this. It's real close. So I can't add anything to the bolt because it'll get in there. But I can add stuff here. And the point that this actually contacts the bolt. Let's hide some of these sketches. These sketches are getting a little unruly. Okay. So the point that this jack, the point that the jack actually hits the screw, I can't see. Or the point that the butt actually hits the nut, or the bolt here, is right there. So that's back pretty far. And at this point in the stroke, we would have basically hit the beater already. If we moved this forward slightly, okay, let's actually go to here, which is where it re-engages. So we can pull this forward maybe to there. That's probably a good amount. So what's our distance here? 2.362 millis. Kind of downward. So if I did 2 mils perpendicular out from there, that's probably pretty good. I mean, I'll do 2.2 just because I could probably do a little bit more than that. So we'll sketch here. Oh. There. Okay. Okay, so that gap. Nope, that's not what I want. Okay, I'm overthinking this. We can kind of just make an educated guess here. At the point of contact, it's going to be right there-ish. So let's put a nice little bumper on this. I think I could probably do just a little circle here at like 4 mils. You know what? I'm going to do something a little bit crazier here. So I moved that. I'm going to drag. Thanks so much for joining, Cogs. Hope to see you on a future stream. Have a good day. So I want to do a sketch on here. And I want to project that there. And then I want to go to the move. And I want to also select. Okay, I can't do that. So let's go before the move for a second. And I want to extrude this out here. Okay, and now when I go to the move, I will also move that there. There, now you can really see where that's gonna be. And if we sketch here, project this, get a circle there. Now we can see exactly where it's going to be contacting. In fact, yeah, and then if we go like this and just take a random point here, we want to come out 2.2. And then come straight down. Okay, so that's where it's going to contact. So it's like right at this base point. So what do we want this contact point to look like? I feel like it doesn't need to be that big. And we can probably do something like this maybe. And like this. And like this. And then to lock this in, don't want to come down here at all anymore. This has to be pretty rigid, so let's add something. And actually, I don't like We actually don't need this straight line because I think I want to make it cup this. Kind of cradle it almost, because I think that'll be quieter. We can try something like that. So something like that to grab it, you know what I mean? And then to lock this in, well, I think we can do something. Oh, oops. I mean, I can literally just come up a bit, come out a bit. Looks a bit crazy, but what does it look like when we add our bumper? Oops. Okay. And then I think to make this properly quiet, we can just do like this kind of deal. So that'll absorb a lot of that energy. That'll really kill the momentum, which is what we want. Right, we can try that. That's a nice little bump. I feel like we are going to be getting a little bit of noise from the jack hitting there as well, because... No, actually we shouldn't, because it doesn't actually ever hit the... Yeah, we're good. We're good there. It doesn't actually hit that. Okay, so this one's done. And then when this guy, when the red guy engages with this, I kind of want to be able to adjust. I kind of want to be able to adjust this. So I'm going to delete these fillies. Cheesy Michael, open up your door. Oh, what am I doing? I need to be doing this guy. Come on, you got it. You got it, dog. You got it. Oops. So instead of... Wait, how do I get rid of this chamfer without just deleting this whole thing? I guess I can go with a sketch on this, project this. Okay, and then extrude this out to here. New body. No, I see what's happening. Oh no, wait, I messed up. Project this. I want to carry that circle. There. And then we can finish this sketch, extrude this and this out all the way. And I'll create another sketch. Oh, my neck. Oh. So I think what I'm going to do here is make this one piece. Oh, shoot. Oh, something hit my roof. Okay, so this will be a bumper as well. Boom. But we will use a screw to be able to push this forward and back. But how do I use a screw to push this forward and back along this arc? That's what I need to figure out. Maybe actually what I can do Oh, this is gonna be nice. This is gonna be nice. So I'll do yeah, this is gonna be really cool. So I'll sketch on here. Let's project all of these things that I did already. I'll create a little track in here. 4mm track. What's this distance? 1.8 versus this distance 2.1. So if I make this just 2, oh yeah. Oh yeah. This whole thing is gonna be okay, and then I take this and I go like this, and I go and extrude. Come on, let me select just one. Yeah, there we go. There you go. There you go. There you go. And I extrude this out. Let's do it. 2 mils. New body. Wait. And this. Actually, how far back does that go? That one goes really far back. Okay, so we can change this angle to that. Finish. This. Target body, tool body, remove, keep tools. Okay. This is going to make sense in a minute. Boom, boom. Then we take this whole circle, extrude it. We go minus 0.5. Should I do minus 1? Let's go minus 1 on that. And then I take, and then I go extrude this, and, oops. This, and this. And then we go minus 0.8 or 0.9, I guess. New body. Okay. And then I go like this and extrude this out to here. New body. Okay. Oh, shoot. Sketch on there. Project this and this. Extrude. Extrude this out to here. New body. Combine these two. Boom, boom, boom. Throw a little filly. Oh, wait. What? Combine. Boom, boom, boom. Don't keep tools. Okay, there we go. Do a little filly here. Do a little filly here. Whoop. And then we do a sketch on here. We draw a line up from this point to I guess I should do this to here and should be 1 milli. Nope, 2 millis. Yeah. And then we go like this. And we go 4.7, I think. And then we go like this, 4.7. And then we go like this, tangent, and this, tangent, finish, extrude this. To there. So now we have this slot. So I'll be able to send a screw through, and I'll have some adjustment in this. Oh. Oh, I should have gone all the way through to there, but I don't want to cut. Oh yeah. Okay. Did that work? Yes. No, it didn't. Because I need these two to be combined, which I haven't done yet. Nice. And then we can go and extrude again. Take this circle only. Go all the way through this. So now I'll be able to send a screw. Send a screw through this guy. The little channel allows this to stay oriented correct. And then the screw will hold it into the place, and I'll be able to move this along this arch a reasonable amount. So I can adjust this, because that's the other thing. We need to adjust this. This will be Multi-Material. This is such a small print. I'm not going to worry about making it. You know what I mean. Can I fillet this at all? Is there any way I can grab that? Yeah. Let's go 2. And then fillet this 2. Great. Look at that. That looks fancy. Love that. So these are separate parts now, but that's okay. Great. That's quite good. Unsubscribe. Okay. How much do you think the infill will affect such a small print? So I probably won't. Like, I'll probably just do this solid. The part that engages with this never actually slams into this. It's always a gradual movement up to this point. So whereas this is a big slam, and that's why I've taken away the center part to try and like reduce any vibration and really make this so it catches the hammer instead of bouncing it. And that's also why I obviously added all the ridges on this guy so that there's like a little less slamming going on. And this one actually slaps. That's why I did a bunch of individual ridges instead of... Now, I'm just realizing how big are these? Ooh, point... I didn't think about this. This is only 0.2 mil. So that actually doesn't work because my nozzle is 0.4. So the lines are going to be 0.4. So I need to change this. It's not going to work. That's not going to work. So how about instead of that, we do kind of a similar thing where we go with maybe a 2-point circle. So I'm going to go like this. I'm going to go like that. And grab my 2-point circle. Come back a fair amount. Like that. Finish. Extrude this out. Okay, what to that point? Why isn't it cutting? Can I just delete this now? Yes. Why isn't it letting me get rid of that? That's annoying. There we go. Bean. And now we're going to create sketch again. Project this. Okay. And then we're just going to go like this, and we'll go minus 0.4. No, minus. Okay, let's just do that. And then we will go with a 3-point circle, because I don't know. Like that. Finish. And then let's just get rid of all this. There. That's gonna be fine as well. Okay. So, what else we gotta do here, folks? So the other issue is this screw. I also really dislike I guess I could just combine these. That could be one part. But the screw rubs into this. So I could just cut out the frame. Yeah, I think I'll just cut out the frame. Literally just need to cut out like a mil. Okay, let's do that. Let's do that. So, mainframe. Let's get rid of some stuff here, actually. So we're going to sketch on this surface. we're going to project this. Was that not a perfect circle? What's going on here? What is going on? Why can't I touch that? I want to touch that. I want to touch that one. Bodies? Okay, we'll do that. Oh. Okay. And I can do a circle from here to there. Is that concentric? Yes. And then I can do a circle that is much bigger than this. How big is this? Cheesy Michael, open up your door. Okay. So 9 mils, so we can make this 10. And then I can just go like this, tangy, tangy. Finish that sketch. Realistically, project this. Thinking we go like this, make that 10. Finish. Can I isolate anything at this point? That would be nice if I could just isolate this body. No, it's so dumb that I can't isolate on this. Okay, so we're just going to disappear some things. Manually, I guess. Okay, now we can see. So I think what I'm going to do is I'm going to push the whole frame back. Like this whole piece of the frame back. A millimeter? Maybe even more. 2 millimeters. And then I'll add 2 millimeters here. Just to keep the strength the same. That looks dumb. Why did that happen? Okay, that's fine. I don't need it to be. You know what? We don't even need this. Let's just bring this back as well. It's better to have gaps. I don't know why I got rid of every gap possible. It's okay to have a little bit of a gap there. It'll make it easier to assemble. Hang on, something sounds weird. Yeah, looks fine. Okay. More of a gap there. Great. I'm happy with that. When you use this, you should make the beat of the song be Morse code. That's what would that sound like? That might be really cool, actually. Yeah, because I can do dots and dashes, essentially. That is possible, I suppose. I might not have time to add the damper in this video. The damper might need to come later. Which I think is fine. The damper should be pretty easy, and then that gives me an opportunity to like improve this even further. So okay. So that works. That works. So now let's start looking at these linkages again. This one and this one I'm going to combine. Link 6. Oh, wait. Yeah, weird. So see how I have this guy here? I printed this tiny little spacer after the fact because this was way too tight with that. $3mm difference, and I don't understand why that was. So maybe let's get rid of this, figure this out. I think I just need to move. I think this thing just needs to move over quite a bit. So let's move this back, -3. So now it's kind of more in line with our green guy. And we can get rid of this. Let's get rid of this too, because that's confusing me right now. Yeah, that's a little better. And then let's just make this whole bar part thicker by 2.5, I guess. New body. Oops. Okay, weird. There we go. Okay. And now the other thing I wanted to do was thicken this guy up. Oh no, I can't really. Well, I suppose I can. Ultimately, I want them to be the same thickness, right? But it rubs there. So the problem I'm having is I want to thicken this guy up. And theoretically, it should be the same thickness as this. So Theoretically, it should be the same thickness as this. Oops. What on earth happened? There we go. Yeah, so now those are the same thickness. But in order to thicken this up, it has to move over. And so just for the sake of... See, these aren't actually lined up in the model, but they are lined up in real life. And that's kind of a weird thing that's happening. Why is that happening? Well, it doesn't matter. I mean, it kind of matters, but... Actually, yeah, why is that happening? I think it's just because like there's like little minor bits of twisting going on between these parts. So let's just shrink this back down again. How much was that? How much did that go down? 0.76. Okay. That's, I mean, that's kind of what's happening. Let's go minus 0.8, give it a little bit more room. No, see, yeah, see, it's still okay. This actually makes more sense. It's actually not good. So we need this to clear. That's what was happening. It was in real life. It was hitting the red part, and so now we're clear there. It wasn't clear before, so that was I guess my mistake. I don't know how I messed that up, but it's fine. This is fine now. If we extrude this minus, and then just to make sure this isn't rubbing on anything. Actually, no, I want to print that flat. I'll probably put like tiny little spacers between all of these joints as well. I'll just print a bunch of, because they're all the joints are the same size, so I can just print a bunch of little tiny spacers, little washers basically. Okay. Why does it keep zooming out like crazy? So those are lined up now. Okay. Now the issue is when I made this guy thicker, now this guy intersects with it there. So we need to cut away a bit of that. But I want to do it in a way that I can make this overall stronger, because this joint is really thin as is, and I'd like to make it stronger. The screw head is just slightly bigger. Oh yeah, and it also hits there too. So this is the other issue. So we're going to kind of redesign this whole thing, I think. So the additional issue is that when this comes down, it intersects right there as well. So we can't have that. So what is this? Link 5. Boom. Capture position. Sketch here. Project this whole thing. Let's project this whole thing. So we know the screw head on this is slightly bigger. So let's just be safe with this. Let's go with a 10 mil screw head. And then the bolt gets in the way there. And we can visualize that by going like this. And by going like this. So I've got to cut away a lot of this meat, which is okay. I can just add it on the back side. So that's fine. Hey, what's up? Nothing. Are you getting the pizza oven going? Nice. Perfect. You can use any of the wood that's out there, too. And some charcoal if you want. But the big issue is this. So if we look at this path. Oh, that's actually not very clear, is it? Because that ratio changes depending on the motion. So let's just do this for a second. I can visualize this as this. Oh yeah, so we can trace the motion. So we can see it contacts here. The red guy contacts the green guy there. So now I can, I can create a new reference, capture position. Okay, we'll sketch on here. We'll project this. And now we can see exactly where it passes through. And we'll also project our circle there. Finish. And then we'll do 3, and then that'll give us 3 contact points. So when this comes down and through, and then we go like this, create a new capture position, and we project. Oh, and then we create a sketch on this surface and project this again, and project this again. So this looks like a mess, but it's very clear. So I'm going to finish this sketch. I'm going to start a new sketch on this surface once again. And I'm going to do a 3-point circle, and I'm going to connect. Okay, wait. Annoying. I'm actually going to do this on the main sketch, and we're going to project that again. We're going to project that. We're going to project that. We're going to project these 3. Circles. Okay. And then we are going to do a 3-point circle this one, and this one. And we're going to project these 3 circles as well. Finish. New sketch here. Project those new circles we just drew. Boom, boom, boom. And then we can go into our sketches and turn all of these other sketches off. Okay. So as you can see, it'll never actually get down to this point. But once again, we'll project this and we'll draw our 10 mil circle to represent the head of the bolt. And that 10 mil circle then carries through I mean, I guess I just need to, realistically, I just need to cut out that chunk. And I need to cut out this whole chunk, as well as the path that this bolt takes. Wait, what? The path that this bolt takes. Okay. So if I finish this, now we can analyze. In our motion, we're watching for the red. As this travels up, you can see the red remains. It's kind of intersecting above our circle there, but that's okay. I'll just remember that. But the bolt head, which is this circle, remains within that ring. Okay. Good. And then this one, where the bolt interacts with this, yeah, we just gotta cut that out. Okay, so easy peasy lemon squeezy. Lemon squeezy. Easy peasy lemon squeezy. So this is the path we need to remove from this, but obviously we can just make this curve better. Oh, my neck. I want to project this. I want to do maybe maybe a tangent arc. How does a tangent arc work? I can't do it because it's not a full circle. Okay. That's okay. That's okay. We can start here and end up here. Can I tangent this to this? Boom. And tangent this to this. Boom. Now that makes it huge. So let's shrink that down significantly. Okay, that works. And let's do another 8 mil there. And can we just offset this guy? -8. Yes. Now if we extrude this, excuse me, to here. Okay, we've got a real skinny boy there, but that's okay because we've planned for this. So now we extrude all of this nonsense. Here. Okay. So that's our new link. Looks like a little banana thing. These look kind of dumb. But that's okay for now. That's okay for now. Because we will be able to... Oh, banana bread. Oh, okay, Ruby, I gotta show banana bread. I gotta show banana bread. I'm just gonna show you on the webcam though, because I already took apart my whole phone camera rig situation. Check this out. You know what? No. I'm gonna set up the phone. Here, give me 1 second. Wait, is it working? No, it's not. Okay, give me 1 second. Give me 1 second here. Okay, you ready for this banana bread? Okay. Super zoomed in, which is fine. Check this out. So you can see linkage works. And when we launch forward, mallet falls back. Mallet is now retracted. And watch right here. That pushes it up and re-engages. It works. It's not perfect. It's not perfect. But it works. Isn't that crazy? So, what we're doing now, we're just beefing things up, making it a bit stronger. There's a few areas where screws are touching things that they shouldn't be touching. And there's also that loud click sound that happens. And so to defeat the click sound, we've added in these. So this is the new hammer butt mechanism, or not mechanism, but the new hammer butt. Oh, hold on. This is like so hard to deal with right now. So I've added in these rubber or TPU stops. That's gonna this one here is going to try and catch the mallet, because right now when it bounces back, it bounces a bit. So this is going to try and catch that. I've made the point where the pusher engages. I've made this adjustable, so now this can slide back and forth, and there will be a screw that ties it in. So we'll be able to adjust the point that it actually does its job. Added this TPU bumper here, so that should stop the click sound we get. And yeah, now we're just making these beefier and trying to reduce any areas where it rubs. Like this is a big area where it's rubbing right now, which I'm going to just actively about to reduce. So right now the red guy collides with this. Why aren't you letting me move? Yeah, the red guy collides with this, so I'm just about to shave that all away. So to do that, let me get this back down into its kind of lowest position here. Actually, I'm just going to undo because I had it set right. There we go. So in order to do that, so we just need to cut out enough of this. That should be enough there. And it's touching there as well, so we're going to want to get rid of that. Just to be safe. Like that's probably good. And since we're sort of in the phase of just like refining, I'm happy to sort of be a little less careful here. So we want to obviously cut out enough that not only the red part. Okay, let's go -4 on this, I guess. So we're cutting out a lot. And I'm gonna have to make up for this somehow. So let's take a look. Let's see what we got going on here. And let's just push this down this way. We got plenty of room up top. Okay, so let me get rid of this this crazy sketch. And reintroduce our hammer cam. So now that's very clear. Lots of space for the screw head, but obviously this is highly weakened now. So let's bring our frame back in. And see, does this... Yeah, there's no situation where this actually passes in front of the frame. So I'm free to just add a bunch of material on the other end of this. Okay. So I'm just going to beef this boy up. Oh my god. Oh, you know what the problem is? I have my computer set so far back so I could put the pedal. There we go. This is going to be much easier on my neck. I'm going to go with gamer mode here. Sitting back like this. So... what do I want to do? What shape do I want to make this? Let's make it kind of look like it's going to line up with this at some point, but it never will. But that's okay. And then up here... Hang on, where's our main frame? Oh, it's there. Oh yeah, so we're good. Finish. And what did we do? 4 mils? Let's do 4 mils again. Holy printer, what are you doing? Okay, so that's a beefy boy. I don't know, I'm just gonna add fillets and stuff. Okay, doesn't look that cool, but at least it's gonna be strong. It's gonna avoid the screw there. So that's good enough for me right now. That's good enough for me right now. And then the last thing I wanted to do was our link 4. This guy. Okay. So link 4. wanted to make this way stronger as well by doing this, doubling it up. These aren't perfectly aligned, are they? That's fine. Maybe we'll go like 15 on these. I mean, it's strong enough. Everything's strong enough. But I just want it. I'm noticing the screws are like racking a little bit. So I'm hoping that'll kind of help with the racking. But here, I didn't want the screw to be out so much. So that's why I only have one on the top, because this is going to provide all the support. But let's see if this interacts with anything poorly, because it might. So when this comes up, we're good. Oh, no, we're not good. Oh, we're not good at all. So let's adjust this. Oh my god, banana bread. Those are fighting words. That's not what I want at all. So this needs to change. so I gotta make room for this. Okay, now that's got room. Don't know what's going on here. And we're almost good. That's right. What do they say? Never. What do they say? Make something about make sure your moves are unpredictable or something like that. What's that like? Oh, see, my phone's dying. Okay, and then I just need to clean this up. Oops. Circle. Tangent this. Nice. Project this and parallelize. Zoom. Great. Okay. That is that. So we've freed up our linkages. Things are looking free now. We've strengthened a lot of this. Okay, I'm not really sure what is going on here. Doesn't matter. We've freed up a lot of this, strengthened it all. The last thing I wanted to do, and then I'm going to go because we're doing pizza night and she's got the wood stove all burning up now. The last thing I wanted to do, oh no. Where's my hammer cam? Oh, it's way back there. Oh, it is broken. There we go. Fixed it. Right, so last thing I wanted to do was to make the jack. Yeah, she makes some sourdough crust from scratch, and it's so good. And we're doing pierogi pizzas. So I'm a lucky boy. I'm a lucky boy. One of these sketches. This one gives me the line where the jack needs it. Okay. All good? Yeah. Yeah, I'm just about done. Not gonna lie, there's a salmon pizza that is amazing. So I don't know, tuna might be okay. Pineapple, I like it. Relish, I like it. Ranch, love ranch on pizza. But plant cheese is that's where you lost me. You lost me on the plant cheese, but everything else, I'm open. Everything else, I'm open. So, yeah, the last thing, I just need the pusher. I forgot to model that onto this version of the frame. And I want to make it adjustable as well. I want to make it adjustable as well. And I feel like what I need to do is I need the jack to stick out more. So just for the hex of it, let's pop this out 10 more millis. That's like so weak, but we have a lot of room on this side, so I can always beef that up later. I can always beef that up later. And then for the actual pusher, I think I'm just going to do like a straight up guy. Straight up guy. Oh yeah, and this can come out all the way now because my bolt goes the other way. So but anyways, I'm just gonna what am I doing? I'm just gonna come out to the front here. No, I'm just gonna come straight down. We're gonna tangent this boy. And we're going to perpendicular this boy. Oh. That's the worst, actually. So I'm going to get rid of my tangent boy and move this back. Okay, I'm actually going to go all the way back here because I want to have ultimate adjustment. looks dumb, but I don't care. And then we're going to sketch on this face. And it really doesn't matter where this ends up, does it? There, let's project. Well, that's fine. I'm just going to do a circle right here at 4.7. And then I'll just have a screw in there that I can adjust the distance between here, and that's how we will set our jack lifting position. Banana bread, stop. You're lying. Fried rice on pizza sounds amazing. Holy, that sounds amazing. Okay. So those are all the fixes. I'll print these throughout the next day, and we'll reassemble. I might mess around with these and make them look a little bit better. Some of these look bad, but we'll see. I'll print them first because we know at least the geometry is there. And then we can test out all of these different things. And then once we do that, we can run another test, and hopefully this will work better. The big thing I'm banking on is that reducing the tooth size of this will help make the mechanism work faster, and having the adjustments here and here will also help, because I literally, to make it work today, I just drilled a hole in this and screwed a screw in. So there's zero adjustment there. Okay. That's that, folks. I have some new discs printed for the Siren, but I'll do that I'll show you that on Friday. As well as this updated pedal thing. Yeah. That's it. That's it for today. Thank you guys for hanging out. As always, so great to have you. I'm going to go have my pizza. I'm not going to put any fish on it or fake cheese, but I promise you it will be amazing. See if milk commercials were honest. It's only 3.5 minutes long. Great. Thanks, guys. Take it easy. Have a good night. See you on Friday.